everyone, welcome back. We're going to be talking about measures of central tendency and position in 12.3. So in the last section, we looked at graphical displays and how to organize data. A lot of times in statistics, we're interested in locating the center of the data, and the center tells us a lot. And usually when we look for the center, we also look for measures of dispersion as well, which we'll talk about in 12.4. And the measures of center, or sometimes referred to central tendency, that we're going to focus on in this lesson are the average, which we refer to as the mean, the median, and the mid-range. And we're also going to look at the mode, which is the number that occurs the most in the data set. Okay, think of the mode as the peak in the histogram. So when we're looking for the mean or the average, there's two kinds that we are interested in. One of them is the population average, and that's symbolized using a Greek letter, and we use the letter mu. However, we talked about how it is difficult to find population anything because populations are so large. So instead, we draw random samples. And when we take a random sample, we also find an average, which if we take a good sample, it should represent our population average. We use a different symbol for sample averages. And the symbol that we use is referred to as X bar. It's an X with literally a bar on top of it. Some books may use Y bar. It doesn't matter. Anytime you see a variable and you see a bar over it, that represents the sample average. But I believe your book uses X bar. Okay, but just know that the bar represents average. So to find an average, all we're going to do is we're going to add the numbers in the data set and then divide our total by the number of pieces of data in the set. The fancy way of writing that is using the Greek symbol sigma. And anytime you see sigma, which is the symbol here, it refers to summing. So you're going to add. And it's just saying take all of the data values and add them and then divide by n. And n is your sample size. And we know X bar is your sample average. So let's take 5 firefighters' ages and let's find the mean. So if I want to find the mean, that's a sample of all the firefighters, in the world. I'm finding X bar, and X bar is the sum of all the values divided by the number of values in that set. So here I'm simply going to add 30 plus 21 plus 51 plus 37 plus 51, and I'm going to divide by 5 because there's 5 numbers there. And when you add the numerator, you get 190. And when you divide, you get 190 divided by 5, which is 38. So the average age of firefighters in that sample is 38 years old. Another measure of center we look at is the median. And the median is the middle number in a set of ranked data. Ranked just means the numbers are in some type of order. It could be least to greatest, greatest to least. Doesn't matter. All we're going to do once we put the numbers in order is pick out the middle number. So I'm going to take my firefighter numbers, ages, and I'm going to put them in order. So I would have 21, 30, 37, 51, and 51. And if I simply count off first and last, and get to the middle, my median is 37. So that's the median age. We do have a symbol for median. It's not commonly known, but it's a squiggly, like a tilde on top of the X. So my median there is 37 years. That's the median firefighter age in that sample. Now, what happens if you have two numbers? What happens if you have an even number of numbers? In that case, we had an odd number. We had 5 ages there. So it was easy to pick out the middle. But when you have an even number, what you're to do is just take the average of the two middle numbers. So you'll see that in this next example. So try pausing the video, see if you can find the mean and median for the following set of numbers, and then unpause when you're ready to go over it. So first I'm going to find the mean. Remember, this is my sample mean. And to find the mean, I'm going to take all my numbers and add them and divide by the number of numbers. So here I'm going to add all those numbers. And then I'm going to divide by 8 because there's 8 numbers. When you add the numerator, it should be 146 divided by 8, which is 18.25. So that's my average. And the reason it's called a measure of center is because it's about the center of the data. 18.25 would be approximately in the center if you were to line all of those numbers up, as you'll see, because I'm going to do that now to find the median. So I'm going to put them in order. And you can see 18.25 is right about there in the center. So that's why it's a measure of center, or we call it central tendency. Now I want to find the median. So typically it would be the middle number, but if you start crossing off values, you'll see there's two numbers in the middle. So when that happens, we're going to find their average. So you would just add and divide by 2. So 17 plus 19 gives you 36, and when you divide that by 2, you get 18. So the median is 18. Let's talk about the mode. So the mode in a data set is the number that occurs the most. In the last section, we saw the modal class, which had the highest frequency, because that was the one that occurred the most. Does every data set have a mode? It doesn't have to. You can have a data set with no modes. Can a data set have more than one mode? The answer to that is yes. Sometimes in statistics, we'll look at things that have 2 modes. And we refer to that as bimodal. One mode is referred to as unimodal, the prefix uni meaning one mode. Can you sketch a histogram that represents a data set with no mode? So try to visualize that. I'll give you, some time. So pause, try to sketch a histogram, and then unpause when you're ready to discuss. So remember, the histogram is where there's peaks in the graph. If there's no mode, there won't be any peaks. So if I was to look at a graph, a histogram, they would generally all be the same height. There would be no peaks. So that data set would have no mode since there's no peaks. And if our midpoints are the following, right, and so on, it's just saying that there's, let's say, that's 5. There's 5 1s, 5 2s, 5 3s, and so on. So there are no modes. There's no number that occurs the most. They all occur the same number of times. See if you can find the mode of the firefighter's ages. So in this case, I need to look for any numbers that repeat the most. And the one that occurs the most is 51. So 51 is the mode. So now that you've looked at those measures of central tendency, now let's look at the mid-range, which is another measure of center. So if we break the word mid-range down, range is highest minus lowest. If I want to find the mid-range, it's the middle. So it's the middle between the highest and the lowest values. The formula is lowest value plus highest value divided by 2. It's kind of like the midpoint. So if we want to determine the mid-range of the firefighter's age, I need the lowest age, which would be 21, and the highest age, which is 51. So to find the mid-range, I'm just going to take the lowest age plus the highest age and divide by 2. So that gives me 72 divided by 2, which is 36. So after looking at the measures of central tendency, which measure do you think best represents the ages of the firefighters? We're going to talk more about this later, but which one do you think doesn't represent the firefighters? If you said the mode, I would agree. The mode is unlike the answers we got for the mean, the median, and the mid-range. If you look, the mid-range was 36, and the median was 37, and the mean is 38. They're pretty all close together. But when you look at the mode, it's 51. 51's not like the others. So I don't think 51 would be a great way to describe that data set. And we'll talk about why later on. Okay, try pausing the video, and I want you to practice finding mean, median, mode, and mid-range for the following data set that represents salaries of 8 social workers. And then you can unpause when you're ready. So the first thing I'm going to do to find the average, it's the sum of all of the values divided by the number of numbers. So if you add up 40 plus 25 plus 28, all of those numbers, and then divide by 8, you get 363 divided by 8, which comes out to 45.375. So that would be the average. If you place the numbers in order, it would go 25, 28, 35, 40, 42, 60, 60, 73. And if I find the middle, you're going to see there's 2 numbers in the middle. So remember, in order to find the median, if there's 2 numbers, I have to add and divide by 2. So 40 plus 42 is 82, and then 82 divided by 2 is 41. So my median is 41. The mode is the number that occurs the most, and in this case, the number that occurs the most would be 60, because it occurs 2 times. All of the other numbers occur only once. And then last, we need to find the mid-range. And to do that, remember we need highest plus lowest divided by 2. So 25 is your lowest, 73 is your highest. So I'm going to add 25 plus 73 and then divide by 2. And that gives you 49. So as you can see again, the average, the median, and the mid-range are all pretty close together, except for the mode. So when do we use the mean, median, mode, and mid-range to describe a set of data? We're going to discuss more of those descriptions, those data sets that you see there. They are all histograms of different data distributions, and they're all different shapes. And we're going to talk about them in 12.5. But for right now, we're going to discuss a couple. So in this first one here, as you can see, that data set there, it's referred to as the normal distribution. And it's unimodal, which means it's got one mode, which would be your peak, right? So my mode would be right here because it's the peak. And it's symmetric because you can fold it down the center and both sides would match up with each other. Anytime you have a distribution that's symmetric and unimodal, or even just symmetric, the mean would be the best measure of center to use. The mean is very sensitive to data values that are extreme, like outliers. It will pull the mean in the direction of the outlier. If you have a data distribution that's skewed, as these two are, this one here is skewed to the right because it kind of tails off to the right. And this one here is skewed to the left because it kind of tails off to the left. Anytime it's a skewed distribution, you would want to use the median. The median is resistant to extreme values. So let me give you an example of what I mean by that. Let's take three numbers. Let's say I give a test to 3 students and all of them do really well. So they all get 100. The average would be 100. If I change this 100 to a 0, now the average is a 67. But did you notice that the median, the middle number, didn't change? It stayed 100. That's because the median is resistant to outliers, extreme values. 0 is extreme. It's away from the 100. The average, however, is affected. We say in statistics it's sensitive to extreme values. Like the average just changed. It went from being 100 down to a 67. So it dropped 33 points just because of that one data value, that extreme value. So when the data is symmetric, use the mean. When it is skewed, use the median. The mode isn't usually a common way to describe the center unless you're describing the graph and you say it's unimodal or bimodal. But other than that, we don't really refer to it as a measure of center. Home builders might be interested in it. To name a real life example, if they're building homes and they want to know the most common family size, we saw in our last section when they surveyed families the most common number of children. That would be important to them. Retailers ordering things like, for instance, shirts, they want to know the most common shirt sizes. That's the mode. And then the mid-range is usually used when you're studying things that are constantly fluctuating. And when I say fluctuate, I mean like increase, decrease, and it's constantly doing that back and forth. Temperatures fluctuate for different areas of the world. You may want to look at the mid-range for that. So now we're going to look at measures of position. And 2 measures of position we're going to study are percentiles and quartiles. And it literally means like where that piece of data is located, what position is it in relation to the entire set. So if you've taken the SAT or the PSAT, more than likely your score was described as a measure of position, not as a measure of central tendency. They didn't tell you in the report what your average score was. They more than likely told you what percentile you were in. So let's say you scored a 520 on the mathematics portion on your SAT, and it was reported to be in the 78th percentile. Do you know what that means? So what it doesn't mean is that you got 78% of the questions correct. It means that you outperformed 78% of other students who took the exam. So you did better than 78% of students who took the same exam. You can also say 100 minus 78% or 22% outperformed you. So they did better than you did. Let's say Miss Smith takes her 5-year-old son to the pediatrician for a checkup, and the pediatrician tells her that her son's height is at the 95th percentile for 5-year-old boys. What does this exactly mean? So take a second and see if you can answer it. What the pediatrician's trying to say is that her son is taller than 95% of boys his age, and 5% are taller than he is. Another measure of position that we're going to look at is quartiles. So when you think of quarter, it represents 25%. So quartiles divide the data into 4 equal parts, or 25%. So if you think of it like, here's quartile 1, and that represents 25%. Here's quartile 2, that's another 25%. So you end up with 4 25%, which if you add that, you get 100% of your data. So the first quartile is the value that is higher than about a quarter or 25% of the population. So the first quartile would be the 25th percentile. The second quartile is also referred to as the median. It's higher than about 50% of the population. And then the third quartile, or Q3, is a value that's higher than about 3/4 or 75% of the population. So it's in the 75th percentile. So let's look at an example. The Florida Department of Education is concerned about high turnover of its teachers. A survey was done to determine how long in months the teachers have been in their current positions. The responses of a random sample of 27 teachers follow. Determine the first quartile, the second quartile, and the third quartile. So the first thing we're going to do is we're going to organize the data. You can organize it into a stem and leaf plot, or you can just write the numbers in order. So I'm going to quickly do that for you. You can fast forward through this if you would like. So the first thing I want to do is I actually want to find the median, which is Q2. So to find the median, I'm just going to find the middle. I know there's 27 teachers, so I know that the middle is going to be after I get to 13, because 13 plus 13 is 26, plus 1 is 27. So one of the things you can do is just count off and cross off the first and last numbers, and keep doing that until you get to the middle. And I'm not going to do that though. I'm just going to tell you here that the middle number is 17, and you can count. There's 13 numbers to the left of it and 13 numbers to the right of it. So how do I find the first quartile, Q1? The first quartile, think of it as it's the median of the first half of your data. So I'm going to find the median now of all the numbers from 2 to 16. So if I go from 2 to 16, the middle number is 9. You can count. You've got 1, 2, 3, 4, 5, 6 numbers there, and then 1, 2, 3, 4, 5, 6 numbers there. So 9 is in the middle. And then Q3 is going to be the middle of the last part of your data, from 18 to 42. And the middle number there is 24. So what's happening is we just divided our whole data set, all 27, into quarters. So this part would be your first quarter. This part here is your second quarter. Actually, let me do it in different colors. This part here is your second quarter. This part here is your third quarter. And then the last part would be your fourth quarter. So it takes the data and divides it into 25% or quarters. Okay, I would like you guys to pause and try this on your own, and then you can answer when you're ready. You can unpause. The following statistics represent annual salaries for physical therapists in a Florida hospital. So they give us the mean, median, and mode, and then the first and third quartiles and the 90th percentile. So what is the most common salary? When they're asking for the most common, they're referring to which one? If you answered the mode, you would be correct. So the mode is the most common, or 80,000. So the most common salary for a physical therapist at this Florida hospital is $80,000 a year. What salary did half of the physical therapist salary surpass? So for this one, I need to find the halfway point. Which one of those is the half? It's the median. So the salary that half of the physical therapist surpass would be $86,520. About what percent of physical therapist salaries surpassed 93,000? So now they're asking us what percentage. 93,000 refers to the third quartile. Remember that the third quartile is 75th percentile. So what percentage surpassed that? It's 100 minus 75, which is 25%. So about 25% of the physical therapists make beyond $93,000. About what percent of physical therapist salaries were less than 72,000? So 72,000 is the first quartile. And remember, the first quartile is the 25th percentile. So also 25% of physical therapist salaries were less than 72,000. About what percent of physical therapist salaries surpassed 99,000? So 99,000 is at the 90th percentile. So what percentage is more than that? 100 minus 90, which is 10%. And in our last question, if this specific Florida hospital employs 25 physical therapists, what's the total annual salary of all of its employers? So to calculate that, the key is there the total, right? So I can use my average formula to figure this out. Remember, the average is the sum or the total of all the values divided by the number of numbers. So in this case, I know the average. It's your mean, which is 88,000. I don't know the sum. That's what I'm trying to figure out. I do know that there are 25 physical therapists. So if I'm trying to find this, all I'm going to do is multiply 25 times 88,000. And that's going to give me the sum of all of the salaries. When you multiply those together, you get $2,200,000. Okay, that takes us to the end of 12.3. Please email me if you have any questions. Make sure you're working on the homework, especially since the semester is ending quickly, and you'll want to get those grades finalized. And if you have any questions, again, please reach out. Hope you all enjoy the rest of your day.